My name is Andrey, and I'm going to talk about Sshoogr. Many people actually ask me how to pronounce that combination of letters. It's Sshoogr, like sugar, salt, pepper, Sshoogr. So a few words about me first. So my name is Andrey, as I said. I'm Java Groovy developer primarily, and I always position myself as a developer. But in the last few years, I have been involved so much into operations world, actually helping organizations to build the software delivery pipelines, to manage the infrastructure, that somebody may call me actually DevOps guy or automation guy, but I don't like it because I'm still a developer. I still have a developer mindset. Also, I'm a co-author of Groovy 2 Cookbook. I'm a co-organizer of Latvian craftsman community, software craftsman community, which I have here in my heart. Also co-organizer of Devternity, which is another conference in Riga, where I live. I'm coaching at Dev Champions, and you can find my Twitter handle here, so if you want to follow me later, it's quite easy to find. So first of all, before I jump into Sshoogr, I would like to give you background that I had before we created Sshoogr as a library. So, and probably some of you have had the same background as well. Back in the days, there were a lot of Java projects built by Ant, by Maven, and eventually Gradle as well. And the teams I was working in was mostly composed of Java developers. And the problem is that the architectures of those projects were highly over-engineered. Like, application servers, a lot of other stuff, Oracle databases. And I guess most of you guys have been in an over-engineered Java project. Nowadays, Java world is simplifying, so we go to microservices, microcontainers, and all that stuff. But back in the days, we had to manage all this huge stuff. And of course, we had many environments that we had to populate with all that stuff, like installing WebLogic, installing WebSphere, installing bunches of web servers to deploy a simple web app. It was a problem. So the problem is that the other issue that we had is that infrastructure was actually managed and influenced by many relatively frequent changes for different components, different versions of libraries, different versions, new layers were introduced like that. And we wanted to have some kind of simple support for that and simple follow-up on how to handle all these changes. The problem also was that operations guys who were supposed to help us, they were either not available or very slow responding. That was an issue. That was an issue, and we also had to support our own infrastructure for continuous delivery, continuous integration, all the things around development. We had to support them ourselves because operations guys were too busy to actually support production. So everything that was before production, like QA, test environments, and development infrastructure, was supported by us. We had to support it. So we wanted also to reuse our JVM knowledge, our Java knowledge, and eventually also Groovy knowledge. So when we started first, like 5 years ago, 6 years ago, on trying to automate the infrastructure management for our projects, we already at that point we started using Gradle, which was much better option compared to Maven and Ant because that was too hard to maintain. So the first thing we stopped at was Ant plus Gradle. So because, as you probably guys know, Gradle integrates with Ant very well. So, and Ant already has tasks for doing SSH connectivity because SSH was the main protocol we kind of used to manage our environments, to set up things, to connect to them, to maintain this servers. So we needed some kind of SSH connectivity and SCP connectivity, and Ant has that since 90s, previous century. And we just wanted to reuse those. And the problem is that with Ant, that it works, it's nice, but the simple command that we want to call ends up to be something like this. And of course, if it's one command, it's fine. But when we have hundreds of commands, then repeating this kind of code doesn't really work. So at this point, Sshoogr was born. SSH connectivity DSL for Groovy. Therefore, SSH and GR for Groovy, kind of mixed up. So the main feature of SSH DSL is that it can allow you to do remote command execution. More importantly, it can also allow you to do file uploading and downloading. And one thing that kind of you will usually need in enterprise environments is that a lot of firewalls are behind the servers, so you need sort of tunneling to get into the server that you want to. All of those features we needed, and we implemented them as part of the Sshoogr library. One announcement to make is that Sshoogr is now version 09.23, which was released yesterday, just before the conference. Just to show you for the first examples of Sshoogr, is that how many of you guys know about grape and grab in Groovy? Okay, cool. So for those who don't know that, it's a dependency management mechanism built into Groovy. So you can write Groovy scripts with dependencies managed by Groovy in this way. So you can specify the annotation which libraries you want to get from Maven Central or from some other Maven repository, and you can get those automatically injected into your class path without doing anything. Groovy will do that for you. So this is the easiest way to start with Sshoogr. You can grab the library and you can import the DSL as a set of static methods in that class. After that, you can set up some defaults, like what is going to be default user, what can be default key file, default password, stuff like that. Set up different login options, and you're pretty much ready to go at this point. So all the work that happens for making the remote command execution and SSH connectivity happens inside the remote session method, which takes a closure. And inside that closure, you have access to Sshoogr DSL, which is primarily is the exec method and the remote file and SCP methods. So in this case, you see that you can just execute remote commands on some remote server, which is provided through a URL. And we wanted also Sshoogr to reuse a lot of Groovy features, so we made some abstractions inside Sshoogr to, for example, to remote file management. So this remote file, it returns an object, but it's kind of similar to the way you kind of will manage also local files. So, and because as you know in Groovy, you can assign whole file contents to text property, the same you can do for the remote file here and get the file content updated in this way. And thanks to multi-line support in Groovy, you can assign the whole multi-line stat to the file in this way. And because Groovy also has a lot of goodies like left shift operator and appendable interface, remote file actually implements that. So you can actually operate on remote local files like they are actually somewhere locally. So in this case, we are appending some contents to the remote file. In this case, we are appending the whole contents of remote file to local file. And in this one, we are actually chaining this all together. So first, we are putting a message to remote file and then getting the remote file and putting it to a local file. And this all happens thanks to Groovy left shift operator and to appendable interface that remote file actually implements. So pretty nice way to chain up different file updates. Of course, you also have to copy stuff onto the servers from time to time, and that's one of the most used features, I think, at this point. Sshoogr provides a DSL to actually implement the complex copying logic. So in this case, and if you guys used Gradle copy task, the DSL kind of is very similar to that. So you can say that I want to SCP files from local directory into remote directory. And of course, you can switch them around. So it doesn't need to be one way, it could be the other way. So you can also upload and load, and you can also do just provide a set of files which you want to copy to local directory or to remote directory. So you can switch them in different directions. Sorry. Of course, because we are like in a real programming language context, we can use all the facilities that programming language provides. An exec method is not just executing a command. Actually, it takes a lot of parameters in, which you can customize. Also, it returns you a full object of that represents the external command execution result, which you can use in your logic. So in this particular case, what we do is that we get a result object from this command. We don't fail, so we don't get an exception if the commands return something that is not 0. We don't show output, and then in the result object, we actually can do check the exit code, and then we can also do some processing on top of the output that we get from that command. So as you can see, you can build pretty much very complex logic on top of remote command execution. The only thing is going to be local script that will process that logic instead of putting that functionality into a remote machine. Also, there are some shortcuts to kind of make the logic look nicer, because it's DSL. I mean, it has to provide some Sshoogr for Sshoogr. And there's an OK command method and fail method, which I hope is quite obvious what they actually do. So we just execute the command externally, remotely, without failing, and should check in the exit status and just returning true or false depending on what it is. As I mentioned, in enterprise environments and secured environments, you have to have some sort of tunneling all over the place, and you can have direct access to some servers. So it could be that you need a tunnel, SSH tunnel, to do some remote machine and port. So in this case, what we do, we create a tunnel. We're inside our SSH remote connection, and we create a tunnel to a machine that is not visible from our local machine, but is visible from the machine we're connecting to over SSH. And we open a tunnel on that port. And what we get here, we actually get a random port created on our machine from where we execute this script. And we can act on that machine or that URL and on that server in the same way as it is a local machine, local server. So we can actually go to localhost, go to local port that we get here, and we can operate on that, let's say, URL. And in this case, just flushing the cache, but it could be anything. So we could deploy different protocols here. It doesn't need to be HTTP, but it could be something else. Another useful thing that we can realize that we need it, because sometimes you write similar commands and you need to prefix and suffix them with something. And so there's actually a way to prefix all commands that are inside the prefix block with sudo. That's the usual use case for prefix. And for example, if you want to suffix with stuff like outputting all the command output into some log file, you can actually do the suffix as well. Another feature, that actually, it's not just that. I mean, there's some internal features that are available in Sshoogr, like you can actually make the colored output. You can also output get the output of remote commands colored as well. There's download, upload progress. Actually, another interesting thing that actually I didn't know that existed in SSH world. You can actually make SSH connections over HTTP proxy, and that's what Sshoogr also supports. But that was a very weird use case we had in one company, and it works. But just if you need it at some point, you can also use that. So initially, Sshoogr was just a DSL for Groovy, just a library that you can import into your script or into your project and use. But recently, we introduced a command line executable for Sshoogr, which makes it kind of similar to Ansible. And you can create reusable script in this way. So you can say, and you can also keep the connection details outside of the script. So the extension that is used for Sshoogr is Sshoogr, obviously. So basically, the advantage of here that you don't need to install Groovy, which maybe is not the best benefit, but because you have to install Groovy. You have to have it on your machines. But to have a quick start, you can actually only get the Sshoogr executable with all the libs. And you don't need, inside the Sshoogr scripts, you don't need to specify the grep. So you just specify just start writing Sshoogr expressions and DSL. You can omit the connection details, but the connection details will come from the command line. So scripts become more portable in this way. It kind of is Ansible for Groovy. Actually, that's what at least I try to aim for. So the Sshoogr script the simple Sshoogr script will just look like this, without any connection details, without any grab stuff. And of course, the best way, as already Andres mentioned, the best way to get any libraries and any tools from any SDKs from inside Groovy ecosystem and from Java ecosystem is to use SDK-man. And recently, Sshoogr was released on SDK-man network, so it's available there. And the way to install it is as simple as SDK-man usually gets. So first you get the SDK man, which is a simple shell script to manage your SDKs, and then you can just install Sshoogr in this way. Then you get the executable. Okay, there are some other things that available and that may not be as visible as Sshoogr DSL itself, but let's go for them as well. So, how many of you guys use IntelliJ? Wow, that's a lot. So, well, that's what I use as well. And actually, the only reason I switched from Eclipse to IntelliJ was Groovy, because support for Groovy in Eclipse is not, well, it's not there basically. It's just broken. For IntelliJ, it just works. And one thing that IntelliJ has, additionally to supporting Groovy syntax and highlighting and different refactoring options, it also supports extension. You can extend IntelliJ and provide DSL definitions for your DSLs. So you can teach IntelliJ to understand the DSL that you have created, and and the way you do it, you can actually first add a new extension, like for example Sshoogr, and make that extension to be based on Groovy. So you add Groovy file type, you add Sshoogr file type into IntelliJ, and you make it a Groovy file type. And what you do next is actually, whenever Sshoogr jar is on your class path, it will recognize the Sshoogr extension, and it will help IntelliJ to actually do the code completion and method lookups inside Sshoogr script without a need of any additional actions. So if you do that, and if Sshoogr jar is in the class path, then you can do things like this. So you can actually have as you can see, as you can probably see, this is default.sshoogr, which is the Sshoogr script. And when I'm inside, as you see, I don't have any imports or any other dependency management mechanisms. And here, I can actually see that IntelliJ helps me out with DSL support. So I can actually also go to SCP. It will provide me all the things that are inside the DSL. And the way it works, in case you guys didn't know that, the way it works is, oops, the wrong one. What is going on? How do I switch back? The way it works is that with any DSL that you may create, if you provide a special file called with the extension JDSL, which is Groovy DSL, and you use internal IntelliJ API to inform IntelliJ about how your DSL is constructed. So as you see in here. As you see in here, we actually define that remote session method is a special method that is delegated to a class inside sshdSL. This is how IntelliJ can know that our DSL is supported and by which classes. So, and this GDSL file is inside the Sshoogr jar. So whenever it is edited, whenever you have a Sshoogr script and whenever the jar is there in the class path, IntelliJ will be smart enough to actually get it on. So IntelliJ supports Sshoogr. Another thing that was created during Sshoogr development process is sshdmark, because we wanted to test the SSH connectivity, and of course the best way to test it is to do it against real SSH server, and there was no, but it actually takes time to start the server, like in a virtual machine, or have it running somewhere, and it's not always available and takes time. And SSH connection may not be as the fastest thing to actually do. So we actually created an sshdmark for Java that you can use to test your SSH commands against real kind of mocked SSH server, which works with real SSH protocol. So the way it works is that you have mock SSH server class, with help of which you can define expectations for your SSH server. So in this particular case, we define a pattern for commands to return something. And as you can probably guess, what we do here is that we're saying that ls command should return this output, and it should always exit with zero, with exit code 0. And of course, you can get more complex than that. You can define more patterns. You can play with output, play with standard error, play with exit codes to actually to write more comprehensive unit tests against SSH connectivity. And that's what we use internally, and that works pretty well. Also, you can define like file expectations. So you can define what kind of directories and files should exist in our mock SSHD server. And the last thing you do, you just start it. You start it on any port, and then when you test your SSH connectivity, you can actually just pretend that it's actually working against a real server. Also, Sshoogr has integration with Gradle. So originally, we only used Groovy scripts to do different kind of automation. But of course, to do more complex things like deployments and to orchestrate them together with the different SSH connectivity commands, remote connectivity commands, it's always better to have that together inside Gradle. So there is actually a plugin for Gradle called Sshoogr, and the way to import it is kind of pretty similar to a lot of plugins. You just have to specify the apply plugin secure shell. And when you import that, when you apply the plugin into your Gradle build, you basically get the whole Sshoogr DSL available inside your Gradle build. So you can just inside your tasks, you can call Sshoogr DSL methods in the same way you would call it from a script. Also, some time ago, Sshoogr got a little brother. Because, well, I don't know, guys, if you noticed, but actually I have a Windows machine. And I work for some clients who actually have a lot of Windows machines, and, as well as servers. So managing those machines over SSH is not really the option. So the standard way to manage Windows machines is actually over a different protocol called WinRM, Windows Remote Management Protocol. So we created actually a little brother for Sshoogr, which is called Groovy, which is basically a similar DSL for WinRM protocol. So the way you do it is very similar. So you have the exec method, you have the remote file method. Initially, we wanted to kind of join it as a single project, but we quite soon realized that mixing management code for SSH or Linux-based machines and Windows-based machines will never be the same. So there's no point in abstracting that away. So it's better to have two different libraries managing that stuff, because the code for Linux will never be used in the same way to provision the Windows machine. So it will always be different code. So that's why we left it as two different libraries. Another little thing that we created as well, and we used for testing our provisioning code, was punit. Well, initially it was called Puppet unit because we actually used a lot of Puppet for infrastructure provisioning. But essentially it could be actually used just for any kind of provisioning tool, Ansible, Shaft, whatever. So the idea was that we actually, because we started to develop some modules, some generic provisioning code that was reused by several projects and several clients. But we wanted to test that generic code in some way, and of course, because we are Java developers, we wanted to use JUnit to do that, to write tests for our stuff. So punit is basically an integration of Sshoogr and JUnit. I'm not going to jump through examples because that's maybe too specific on them, but basically we have this base integration task where we can run against some. It always runs against some real machine, like AWS server, for example, and after that, after we applied our configuration, we could actually run some tests and write some Sshoogr commands and some verifications against that to get state of our provisioning code, and then verify that and run it constantly. Okay, I'll skip this thing. And of course, because it's a unit test or kind of integration test, we put it all into Jenkins or into CI server, all together, together with the Puppet scripts, together with Sshoogr script, together with Gradle. We kind of get these reports back, which kind of resemble the same things you would probably get from any software project. So we kind of tested our infrastructure as code against cloud servers started on demand, and we tested them periodically in our continuous integration server, which was very handy, especially for the generic infrastructure as code that we reused between several projects. Okay, it's like almost finished. So Sshoogr is actually quite old, I think, at this point. It's like 5 years already, and it has been tested on several real projects. And I'm using it for my clients. I'm using it for provisioning my fleet of Raspberry Pis. So it's working. It's working very well. And it's executable and portable, and it's easy to integrate with any Java library and Groovy library. So this is one of the best things for me, because I can take any Java library, Groovy library, put it into Sshoogr script integrated with SSH connectivity, and have the orchestration, automation, glue be in one script or one Gradle build. Yes, as I mentioned, so Sshoogr can be used for provisioning servers, for provisioning IoT devices, for executing remote orchestration commands, for testing and monitoring infrastructure, state, a lot of things. Everything you can do over SSH, you can program it with inside Sshoogr. Some few things that I'm going to introduce in the next versions of Sshoogr is that we probably go for generic resource definitions, allowing group some commands as a resource, having a special command for creating a resource, updating the resource, to checking the state of the resource. Probably we also have some command rollback, so we have like transaction mechanism for SSH, sort of. Parallel execution, maybe some XSS utilities for saving you from writing non-secure scripts. Yes, of course, better documentation and integration tests will be extended, even though at this point Sshoogr has quite comprehensive test suite, both unit tests and integration tests. Of course, if you guys want to help, I will be happy to board you in. And it's all on GitHub. It's all open source. The two brothers, Sshoogr and Groovy, available there. And I guess that's it. Thank you very much.